Okay, so let's get phones away and let's get going on this. Okay, this may be just kind of mostly review to a lot of you. Students a lot of times have a pretty good background for lines. Kind of depends on you though, but we're going to run through it, make sure everybody knows this. So we're going to look at slope of a line, which we have done. We've looked at slope of a line and average rate of change. So we're going to kind of quickly run through graphing of linear functions and just kind of all the basics that you need to know. So basically a slope is telling you how steep the line is. There's four cases. You could have a positive slope if it's sloping up, a negative if it's going down, zero if it's horizontal, and it's undefined if it's vertical. Okay, I saw this nifty little diagram. I find stuff on the internet all the time. This is Mr. Slope Guy, and it just says this. I like this thing though, it's cool. Okay, it's got, that means positive slope. See, eyebrows slanting up, negative slope, going down. Okay, that's the nose. That's U for undefined. And then that's the zero for his level face like mouth like that. I don't know who comes up with this stuff. Not me, certainly, but I thought that was kind of cool. All right, so there's Mr. Slope Guy. Whatever it takes, you want to make sure that you know these four cases. Okay, we have talked about this, but we already talked about average rate of change. So with this, a slope is a ratio of rise over run. The rise is really just a change in y, and delta x is a change in x, all right? And then this is the general slope formula where you do this. The rise is just nothing more than how far apart are the y values of your 2 points, and then the run is just the distance between the x values like this, okay? So we're going to do this. We're just going to kind of count some of these things out real quick. And when you're doing this on a line, you want to just find two good points. So I'm going to kind of search for two really good points. So it looks like that point 2,5 is a good point. And then the other one I see, I think, and if I'm not doing this right, I have a hard time seeing on this. So 2,5 and 6,8, does that look good? Okay. So basically, we're just going to count this out. So basically what you're doing is you're going from this point to the other. So you're going kind of up, and that would be the rise, and then you're going to the right to get to that point, and then that would be the run. Okay, and it's very logical how you do this. The rise is positive if you're going up, negative if you're going down. The run is positive if you go right, negative if you go left. That's logical. So you can count this out. So it looks like the rise on this is 1, 2, 3. It looks like the run is 1, 2, 3, 4. Okay, so therefore your slope is just rise over run, it's 3/4. Okay, now I do want you to understand the slope formula. A lot of times students have no trouble using the slope formula, but they don't get it. All the rise is the distance between that y and that y. That's what y2 minus 1 says. The distance between 8 and 5 is 3. The run is the distance between the x values. The distance from 2 to 6 is 4. Okay, that's what that formula does, is it just tells you those distances. That's it, okay? So that's how that goes. Okay, next one, let's say I gave you these 2 points, so let's see. The rise on this looks like you're going down 2, so that would be negative 2. The run looks like you're going to the right 4, so you'd have that. Then your rise over run is just going to be negative 2 over 4, and then you want to reduce that fraction like that. So you typically have a fraction as your ratio for your slope. Everybody remember that okay? Okay, this is pretty just kind of intermediate algebra kind of stuff that we're going to look at here. If you take Calc 1 next semester, slope is a real big deal. Okay, you talk about slope all the time when you're dealing with derivatives and so forth. Okay, let's go to the next one here. And on this one, it doesn't matter what the points are. I'm just going to pick a dot and pick a dot there. What would be the rise if the line goes this way? 0. Yeah, it has 0 rise. The run doesn't matter. So I'm just going to say 4. And then the slope would be rise over run. That's 0 slope. Okay. Anytime you have a horizontal line, it doesn't have any steepness at all. So it's a 0 slope. Okay. And then the next one, pick 2 dots. I'm going to pick this dot and that dot. It doesn't make any difference. Okay. If you did this, the rise would be up 3. the run would be what? 0. Okay, so if you do 3 over 0, you can't divide by 0. That's why we say that that slope has an undefined slope. All right, so you can also kind of think of this as an infinite slope. I prefer that you just say undefined, but the idea is that is as steep as a line can possibly be, as if it's vertical, that has an infinite measure of its steepness, like that. Okay, so those are your 4 cases. Everybody with me there and got that down? Okay, all right, I want to also just do the points and do this. Okay, so if I give you 2 points, you don't have to graph define the slope. What you do is, and it doesn't matter which is which, I'm going to just call that x1, and I'm going to call the 4 x2, and then y1 is going to be the -3, and then y2 is the -5. Okay, when you're doing these problems, you just plug it in the formula, and then you're done. So the way the slope would go is you go like this. Okay, you subtract the y's. Okay, so the y values are -5 and -3. And it's up to you which order you subtract in. So I'm just going to say -5 subtract -3. And then I'm going to do the x's in exactly the same order. So I'm going to say 4 subtract -3 like that. If you subtracted in the opposite direction, then just make sure that you're consistent on the top and bottom. So we'd end up having -5 plus 3 over 4 plus 3. So that is -2/7 would be your slope. Okay, like that. All right. Okay, so I just kind of, when I do this, I just do this visually. I just say, okay, my numerator is the y's, my denominator is the x's, just subtract in the same order. Okay. Okay, and the next one, let's see. I'm going to call x1 -5. x2 is going to be also -5, so that means something in the problem. And then the y values, I'm going to say y1 is -8, and then y2 is -6. Okay, so when you do your slope formula, we always use the letter m for the slope. So we'll just go like this. We subtract the y's. I'm going to say -6, subtract -8. Then I'm going to subtract the x's. -5, subtract -5 like that. Okay. So that's going to end up giving -6 plus 8 over -5 plus 5. So that would be 2 over 0. So what's the slope? It's undefined. What kind of line would that be? That would be a vertical line, right? Okay. So that one's undefined. Anytime the x's are the same, it forces you to have a vertical line. That's the idea. Okay, hopefully this stuff we're doing this section is going to be pretty simple here at the beginning and just kind of a quick refresher. That's my hope. Okay, any questions? Okay. All right, and you want to know how to do it both ways. For graphing, you want to know how to count the slope off. You want to know how to use the formula, and you'll do this quite a bit in Calc 1. Okay, let me move to the next page here. And let's see, I don't care about the graphing on this. I think I was just kind of on that was going to have you graph those 2 points. You can if you want to on each example, but it doesn't really make that much difference. Okay. All right, so let's move to the next thing here. So what I want to do on the next page is we'll go ahead and we'll do some graphing, just kind of to get situated on here. So what we're going to do is I give you a point, and I give you a slope, and then we'll just construct a graph. All right, so the first thing you do on this is you want to go ahead and plot your point. So that's left 2, down 6, like that. And your slope's 3/5. It's a positive slope, so it's going to be sloping kind of uphill. It's rise over run. So how do you count that out? If the rise is 3, you go up 3. If the run is 5, you go to the right 5. So it's just up 3. And then to the right 5. And you do that from the point you already plotted. So you'll just go 1, 2, 3 up, 1, 2, 3, 4, 5 to the right. And then that gives you what your line looks like. So if you have a slope of 3/5, that's going uphill. It's a positive slope. Okay. Okay, the next one, -3, 3. You can go ahead and do these if you know how to do these. I'm just going to kind of try to quickly go through the first part of this section. So we have that, and then again on this one, that's the same slope on that, so I guess it'd be the same thing. Hey, let's change the problem. Unless you've already done it, let's change the problem. Let's say it's -3/5, like that, because I want to just do kind of an example of each one. So just change that to -3/5. Okay, well, if you have a negative slope, what I do is I just put the negative in the numerator. Ultimately, it doesn't matter. Just don't put it both places, because then you're changing the problem. So then the rise would be down 3, and then the run, since I'm using a positive number, would be to the right 5, okay? So if you have a negative slope, you would be going from the point down 3, and then 1, 2, 3, 4, 5. Looks like you would end up at the point 2, 0 like that, okay? So a lot of times if a slope is negative, a textbook, and I would do the same, I'd just put the negative in front of the fraction bar. So just have that negative in the numerator. That's kind of a quick way to do that, okay? Okay, and let's see, next two, let's see, we got 6, -5. So I'm going to go over 6, down 5. And if the slope's 0, what do I do? I go this way, okay, like that, okay? 0 slope is horizontal, flat, okay? There's no steepness whatsoever, okay? And then the last one, you want to plot the point 5, -2. And undefined slope, what does that look like? This way, okay? So you just want to know all the different cases like that for slope. Everybody with me okay? Okay, hopefully this will just be kind of a review, but I feel like I want to go through this. This stuff's real important in calculus, just knowing all your functions and stuff. Okay, equations of lines will be the next thing I'm going to look at a little bit. And the different formulas for equations of lines, this particular formula here that we call the point slope formula, you'll use in calculus 1 all the time because you'll find equations of tangent lines. So just kind of want to go over these formulas. The slope-intercept form we've already talked about a little bit is y is mx plus b. The general form is ax plus by equals c. I don't think I've talked about that yet. This is your point slope formula. And in the formula, m is the slope, and then you have a point on the line. All right, you want to know these three formulas right here for sure. I won't ever give those to you because they're so important to know. And then the equation of a vertical line is x equals a number, and a horizontal line is y equals a number. You don't have to memorize that unless you want to, because you can figure that out okay. One thing I do want to mention about this, and you don't need to write this down, but it's worth showing a student that we just got through kind of using the slope formula. Okay, so if I cross multiplied this, let me show you what would happen. If I put the m over 1, I would end up with y2 minus y1 equals m times x2 minus x1. Now notice these formulas are the same thing. Okay, doesn't that look a whole lot like that formula? I just changed the y's. So if you take the slope formula and cross multiply it, essentially you get that anyway. So that's the slope formula rearranged is really what it is. Okay. Okay, let's go next page. Those are just the kind of a summary of the formulas that you need to know something about. And we're going to do some graphing. And then most of the rest of the section, we're going to work with equations of a line. Okay? All right. The next two graphs right here are the easiest graphs there are to do. What happens on this, x is equal to 5. Anytime you just have x equals a number, it means it's only going to go through the x-axis. So what you would do is you just go to 5, and it's going to be a vertical line that goes like this. Okay? Now, one thing, students a lot of times get this backwards. I see it all the time. A good thing to write on your notes is just pick a couple of points. Like, that's the point 5, 4. This is the point 5, negative 2. What I want you to understand is x is always the same. That's why it's vertical, is because x is 5, and it will never change. Okay, that's what that means. Does that make sense? That's why it only goes through the x-axis, is because x always stays the same. It's 5 to the right of the y-axis. Okay, the next one goes like this. If you have a y, then it's only going to go through the y-axis. So this one you would just draw a horizontal line like that. It's a good idea to pick a couple of dots. I'm going to label that as 3, -3. And this one over here is -3, -3. Okay, the thing I want to point your attention to is the y values are always the same. That's why it's horizontal. If you understand the y part, then you'll just figure it out as you go. All right, so that's the idea. Okay, one thing I want to mention is if your equation has 2 variables, then it goes through both axes. So one way that sometimes helps students remember this, if it only has an x, it just goes through x. If it only has a y, it just goes through y. If your equation has 2 variables, like this example, it's going to come in contact with x and y, and that's what causes it to slant. Does that make any sense? Okay, that's one quick way to kind of think about and help you understand that. Okay, this, what I want to do on these is if you have a horizontal line, okay, first of all, anytime you have a horizontal line, that's going to be named by its y value. Okay, horizontal lines would be y equals a number. So if you have the point -3, 2, and it's horizontal, then the answer is y equals 2. Okay, horizontal lines have the same y value over and over again, so that's how you get your answer. Okay, if it's vertical, then it's x equals a number. Okay, so the equation of this would be x equals, and then -3. Okay, I mean that's what I'm saying on that is just horizontal lines are y equals, and then vertical lines are x equals. Everybody with me on what I did there? Okay. Okay, now we'll kind of down at the bottom, we're going to do the point slope formula and kind of get you comfortable with this idea. So if you're given a slope and you're given a point, then the easiest way to do this is to work with what we call the point slope formula. So what you want to write down is just go ahead and write this formula down. And you want to know this formula because, like I say, you'll use this all the time in calculus. All right. So what happens is you just plug in. So the slope goes there. Okay, the x value goes here. That's an x value, so that plugs in there. The 5 is a y value, so that plugs in there. Okay, the x and y are going to be a part of your answer. You want your answer to say y equals mx plus b. So what you do is you just get it set up. So you'll say y minus 5 equals the slope, -2, times x minus -4. And of course, anytime you see that minus minus, then you need to resolve that to a plus. Just write a step like that. So that's how that gets set up. So we'll have y minus 5 equals -2 times x plus 4. Okay, does everybody understand how I plug that in okay? Okay. And now we're just going to do a distributive property and solve for y. So we'll have y minus 5 is equal to -2x minus 8. So again, I'm doing a distributive. Then I'm going to add 5 to both sides. So I get y is equal to -2x minus 3 would be the answer to the problem. Okay, so if I say slope-intercept form, that means that you're looking at y equals mx plus b like that. Okay, all right. Does anybody know how I would check my answer to this? I mean, that's something a lot of times students don't know, and you should. It's real easy. Plug the point in, exactly. So you take your answer. I'm just going to do this one time. You can plug in your point. So you have a point -4, 5. Plug the -4 in there, plug the 5 in there, and see if it works, and it will. Okay, so that one you would just end up having 5 equals -2 times -4 minus 3. That works. Okay, so these problems are 100% checkable. You can always just take the point and plug it into your answer, and if it works, then you're right. Okay. Okay, the other thing I want to do is the general form. I haven't talked about that yet. So when you're doing the general form is ax plus by equals c is what you do on that. So if you've got the equation y equals negative 2x minus 3, then all you really do is just get all the x's and y's on the left side and then leave the number on the other side. So you would have 2x plus y equals negative 3. Okay, so the general form, just have your x's and your y's together. Usually you can just kind of rearrange that y equals mx plus b in your head like that. Okay, everybody solid on what I did? Okay, so if I give you a point and a slope, you want to use the point slope formula. Okay, so let's see. The next problem, I've given you 2 points. And again, you're going to have to do this. The first thing is you want to look at the point slope formula again. And we're going to work with that. But before you use that, I didn't give you what the slope was. So you need to find the slope between those 2 points by using the slope formula. So we're going to start really by finding m. So we're going to use the slope formula to do that. Okay, then it will be just kind of repetition of what we did in the last problem. You'll use the point slope formula. Okay, so I'm going to go like this. I'm going to do the y's. I'm going to pick this order. So I'm going to go 4 subtract negative 4. And then I'm going to do the x's in exactly the same order. So that's 1 subtract negative 3. So that looks like 4 plus 4 over 1 plus 3. So that looks like 8 over 4. So that slope's equal to 2. Okay? So the 2 goes in there. Okay, now what do? I pick a point, and you can use either point. It doesn't make any difference. You'll get exactly the same answer regardless of which point you use. So what I'm going to do is I'm going to pick 1, 4. Now, I guess my thinking is it's positive numbers. Maybe I'm less likely to make a mistake. Okay, so the x value is going to go here. The 1 is going to plug in there. And then the 4 is going to plug in for y like that. Then you just plug in, and then we're going to solve for y and then put it in the general form. Okay? All right, so what we would have is y minus 4 equals 2 times x minus 1. That's the setup. So that would be y minus 4 equals 2x minus 2. Add 4 to both sides, so you get y equals 2x plus 2. So that's what you want to do if you're given 2 points, is find the slope first and then plug a point in. Right? How do I check? You'd have to plug both points in and see if they work. If both points plug into that correctly, then you're okay. Right? And then on the general form, all you got to generally do is just move the x. So you would have negative 2x when you move that plus y equals 2. And that's the solution. Okay? Okay, so general forms ax plus by equals c. Slope intercepts y equals mx plus b. So you want to know those 2 formulas and what they mean. Okay? Everybody with me okay? I'm going to do this pretty quickly because of the review. And the level of difficulty in this shouldn't be too bad for what we're doing right now. Got a lot of arithmetic and then knowing the correct formulas. Okay? All right, everybody ready to go next page? Anybody still? I try to kind of see where you're at. Everybody with me? Okay, all right. Okay, so let's do this one. I'm just going to kind of do an application of what I just did. And then we're going to get into the graphing and then probably one other kind of application on this. So this would be an example of something that has a linear relation. This says if someone's making a telephone call, 5 minutes is going to give you this cost. Okay, so we have 5, I'm just going to write down 5 minutes, costs $2.50. Okay, then there's another piece of information that says a 15-minute call is going to cost $6.50. Okay, so what you have on this is what they're saying is they say the cost of making a call is y, and then the time is going to be x. Okay, so what we get then is we're going to have xy is going to be our point. So really we just have 2 points. We have 5, 250. I'll just write as 2.5. Then the other one is 15 minutes, goes with 6.5. Okay? And then I have to tell you it's a linear relationship, which I do. I say it's a linear equation. So what you would do on this to find that linear equation is exactly what I did on the last problem. You would have to find the slope, use the point slope formula to build your formula then. Okay? So that's what the problem is saying. Okay, so let's see. Step 1, we want to find the slope. Okay, so again, just subtract the y values. Okay, doesn't matter which order you do it in. I'm just going to go 6.5 minus 2.5. Then I'm going to do the y's, and I'm going to do them in the same order. Be consistent in your order. So I'm going to do 15 minus 5 like that. Okay, so it looks like the numerator's 4, the denominator's 10, and I'm just going to use a decimal because we're talking about money, so that's 40 cents. So what that means really is this, and this is worth noting on this problem. A slope is a rise over a run, so I want to kind of see if you guys understand what this means. All right, the 40, what it means is the 40, every time you talk for 1 more minute, which is this, then it's going to cost you 40 cents more. Does that make sense? Okay, if it's got a slope of 0.40 over 1 in the context of this problem, every extra minute is going to cost you 40 cents. That's the idea. Okay, then what we do is we use the point slope formula. And what I'll do on this then is just pick a point. So it's up to you which point you choose. I'm going to use the 5, 2.5. So I'm going to put the 5 in for x1, the 2.5 in for y1, then the slope is 40 cents. Okay, to me it's just logical to use decimals for the money value. So I would have y minus 2.5 equals 0.40 times x minus 5. And then that will give y minus 2.5. Distributive property is going to be 0.40x. And then that will be minus 2 if you do 0.40 times 5. Then we can just add 2.5 to both sides. So your answer would be y equals 0.40x plus and then 0.5. Okay, like that. All right. Okay. Is everybody with me what I did there? Okay. So a couple of things that are worth noting on this. This is usually like what we would call a fixed cost. So like this company is probably charging 50 cents regardless of whether you use your phone or not. And then this is the variable cost, which just means each minute costs 40 cents. Okay, that's the idea. So that's what the mathematical meaning of that problem is. All right, so I'm just going to mention this. You don't need to write this down or anyway, but there's the formula that converts Celsius and Fahrenheit. So one way that you can do this is you can take 2 points. Like for instance, in Fahrenheit, you have like the freezing point is 32 degrees. And then like in Celsius, it's 0 degrees. So you can actually get 2 points, and that's how you get that formula. I can't remember what it is. Fahrenheit equals, I can't remember, 5/8 something x minus c or something like that. But it actually comes from taking a point that you know on Celsius and taking a point you know in Fahrenheit and doing the same thing I just did. That's where that formula comes from. Okay, that's a good problem to show. I just want to mention that. Okay, so let's do the graphing, and then we'll kind of finish up with one application of this. So you definitely want to know how to graph a linear function without relying on your calculator. So with this one, we've talked about this before. The slope is the number in front of x, so that's going to be 2/3. And then the y-intercept is the number -4. Okay, when I have you do a y-intercept, I prefer that you write it as a point. -4 is not really the y-intercept, it's the y value of the y-intercept, but the y-intercept is at 0.0, -4. Okay, so to graph this, what you do is this, you just go down 4, put your y-intercept right on the y-axis, and then if the slope is 2/3, the top number is rise, so that's going to be up 2. The bottom number is to the right 3, so you're going to do that to get your next point on your graph. So we would go up 2, 1, 2, 3 like that, and that gives the line. I'm going to show something on this also, is when you go up to right 3, you end up at the point 3, -2. Okay? Now, there's a way to verify that that point's right. Do you know how you do that, just to verify it's right? Plug it in, exactly. So, I mean, if you want to check, I mean, it's easy enough to do these problems. I'm just saying, hey, you got y equals 2/3, x minus 4. You can just plug in. The y goes in there, the x goes in there. And I'm not going to do the details of that, but it would check if you plug that in, okay? Because that's what a graph is it's a picture of all the solutions of that equation. So you could verify that 3, -2 is a solution of the equation, okay? Okay, any questions? Okay. Okay, tell me on this one. That's in general form. So if you were going to graph this by finding the slope and y-intercept, what would you have to do first?
Convert the equation to slope.
Yeah, find y equals mx plus b, right? So this one you want to solve for y. Because we're not doing intercepts or anything. We're just doing slope y-intercept. And you can do this in your head. You can move the 5x to the other side. So you would have 2y equals -5x plus 10. Okay, then divide by 2. So that's y equals -5/2x plus 5. And then you can graph that the same way you did the last problem. So the slope is going to be the -5/2. The y-intercept is going to be the 5. Okay, and as far as your slope goes, the top number is -5, so that would tell you that you go down 5. Bottom number is positive, so that would tell you that you go to the right 2. So your graph should go like this. You start with your y-intercept, then you go down 5 to the right 2. That would end you up at the point 2, 0. And then you got your line like that. You could plug 2, 0 into the function, and then it worked. Okay, try to do this in your head too. This is easy. A lot of times to me the standard form is easier to check in. So x is 2, y is 0. 5 times 2 is 10. 2 times 0 is 0. So 10 plus 0 is 10. Okay, that's how I know that point's right. Is just plug it in. And there's times when you can just do that in your head. Okay? Okay, any questions on what I just did? I think we did this in an earlier section just a little bit. The way you do this on MyMathLab is pretty easy. You just take your mouse and you click on the y-intercept, and that establishes the point. Then you just kind of move to the next point, click on your mouse, and then it'll draw the line. There's a line tool on there that's pretty easy to do. Okay? All right, any questions? Okay, everybody with me there? Okay. Okay, so let's do this, then we'll kind of do the intercepts. I'm just trying to kind of get you through all the main ideas about linear equations for today. So the slope on this one is 2. The y-intercept's -3. Now, if you have a whole number slope, you always want to put that over 1 so that you can do both the rise and the run. So put that over 1. And then the graph goes like this. So you would go up 2 for the rise, since it's positive. Then you would go right 1, because that's positive also. So I'm just saying, anytime you have a whole number slope, put it over 1, and then you got it. So here I'm going to put the y-intercept first, then go up 2, right 1. Then you got what that line looks like. It's like that. So those are the different kind of possibilities you have for graphing a line. Okay, so next step that we want to look at is finding the x and y intercept. and then just graphing this way. So we're not going to do the slope-intercept form. I'm not going to solve for y. I'm going to do this one a totally different way. So the idea is if you have an x-intercept always has a y value of 0. A y-intercept always has an x value of 0. That's what you got to understand. So all you do on this, when you find an x-intercept, take the equation I give you and replace y with 0. So we'd have 3x plus 4 times 0 equals 12. Okay, that becomes 0, so that just sort of crosses out. So you get 3x equals 12. And you can do that in your head, or you can divide by 3, so you get x is equal to 4. So your y-intercept is 4. I'll show you how you can do this in your head, too, because a lot of times if it's in general form, it's pretty easy to do. Okay? Okay, the y-intercept, you do the same thing. You just set the x value equal to 0. And then you solve that equation. So that would give 4y equals 12. Divide by 4, so you're going to get y equals 3, like that. Okay? Then all you do is just plot those 2 points, connect the dots, and then you got your line. So a lot of times, if you're in the general form, it's easy enough to do the graph in your head, and I'm going to show that to you real quick. So what I do here is just put my x-intercept, my y-intercept, and I got it. Okay? Now let me show this. A lot of you probably have done this before. So if you're in general form, which I am here, this is all you got to do in your head to get the answer. If you want to do an x-intercept, just block that off. What's the solution to that equation? 4. If you want to find the y-intercept, block off x. What's the solution? 3. See what I mean? There's your x-intercept. There's your y-intercept. Okay, so a lot of times if you're in general form, you can do that really quickly and just do it in your head. And you want to be able to do stuff like that if it's in general form. Okay? Okay, the next one, let's just kind of do this that way. Okay, so if it's an x-intercept, block off y. So we would have negative 2x equals 8. Okay, if it's a y-intercept, block off x. So you would have negative 4y equals 8. Okay, you don't have to show the step that you're setting y and x equals 0. You can do that in your head. So here you would divide by negative 2. So you get x is negative 4. Here you divide by negative 4. So you get y is equal to negative 2. All right. So what you'd end up having is your x-intercept would be negative 4, 0. Your y-intercept would be 0, negative 2. Okay. Does everybody understand how I'm doing that in my head? Okay. So we do this, plot the 2 points, and then you got what your line looks like. So to me, if you're already solved for y, it's usually just as easy to just do slope-intercept form. If it's in general form, it's usually very easy to just get x and y intercepts. Get your 2 dots, and then you're in good shape. Okay? Everybody okay? Solid? Okay. All right. Okay, so let's see. I want to kind of go through, probably one last thing here is probably go through this, and this is worth going through, just kind of the basic concept on here. So this is kind of a typical thing you do like in intermediate algebra. So 2 lines are parallel if they don't cross or if they don't intersect. Okay, like I've got 2 parallel lines there. So just want to kind of see, I think probably most of you know this. On those 2 parallel lines, what is the same? The slope. What's different? The y-intercept, right. Okay, so that's what that is. I mean, that's what slope's doing. So you have the same slope, but then you have a different y-intercept like that. Okay, so that's the fundamental concept that you want to know. So I think I'll do just kind of do this one parallel problem. We'll go through this a little bit, and then that's probably as far as we get today, then we'll finish this up next time. So with this one, what I want you to do is this. Just plot this point on the graph I gave you. So let's plot, go over 4 and then down 4, like that. Okay, well, what you would do on this is you'd have to figure out what the slope is. So if you're going from here to here, it looks like 1, 2, 3, you're going up 3. And from here, 1, 2, 3, 4, you're going to the right 4. Okay, so what you'd want to do on this is take this point right here, and we're going to do this. We're going to go up 4, up 3, right 4, from the point that you drew. So I'm going to go 1, 2, 3 up, 1, 2, 3, 4. I think I got that right. 1, 2, 3, 1, 2, 3, 4. It's hard for me to see that. Now just do it backwards. I mean, the thing is, you can do the opposite of up 3 over 4, would be down 1, 2, 3, and then left 1, 2, 3, 4, like that. So you would end up having a line that looks like that. Okay, so the point is parallel lines have the same slope. That's what made that parallel. Now let me ask you this question. Can you tell me what the equation of that yellow line would be in terms of y equals mx plus b in your head?
3/4 x plus...
Right, the slope's 3/4. How about the y-intercept, just by looking at what I did? Yeah, -7. So it looks like you have y equals 3/4 x minus 7 like that. Okay, and that's the idea. All right. The purpose of this problem is just kind of conceptually to get you understanding what the parallel lines look like. Okay, same thing on this one. Let's just finish this up, and then that's probably where we'll stop here. So we have the point 5, 0. Okay, if you do this slope, now so you can do the slope backwards. What I'm going to do is go up 2, and then I'm going to go to the left 5. So that means the slope would be positive 2 over negative 5. So that's a negative answer, so it's negative 2/5. Okay, so what I would do here is just kind of go up 2 to the right 5. I would end up, it looks like I have a y-intercept of 2. So I would end up on the problem, if I have y equals mx plus b, my slope is negative 2/5. My y-intercept's 2. Okay, so the answer to the problem, the equation, would just be y equals negative 2/5 x plus 2. Okay, so that's the idea. That's you're not going to do problems like that, but that just kind of gives you the idea of how parallel lines work. Okay, so hopefully this stuff here is mostly just total review that we'll come right back to you. We'll finish this up next time in class. And then we'll do the 2-1, bring the 2-1, and you guys need to print out from Canvas 2-2 and 2-3. Don't forget to do that because I won't print these. And 2-1 is takes me like 10 minutes to teach. It's like super short. 2-3 is what we're going to spend most of our time on next time. All right. And when's the exam? Next Wednesday. Okay. So if you want that review that's on my math lab, you can just kind of do a little bit of it at a time. And what I did is I just picked out the main problems. When I write my test, I'm going to look at that review that's on my math lab and just kind of pick similar problems, shorten it down a little bit, obviously, but that's what I look at, okay? If you didn't turn in written assignment 1, bring it up, or if you need to send it to me, PDF, I'll take PDFs, I won't take JPEG. That's a great little app called Cam Scanner. Just turns your phone into a picture taker and it turns it to PDFs automatically.